Okay, see if you can get this one without seeing the solution first. Come back and check your answer. We've got two blocks. One is sliding along with some contact that is frictionless. Ask your English teacher. Block A, right? That's the one sliding, and block B is just going down with frictionless pulleys. We've got to find the free body diagram and kinetic diagram of each of those so that we could then say, how fast are they accelerating? Something like that. Or what friction force is needed to slow it down to a certain speed. So something along those lines would be possible. So we could say, let's make an XY fixed at the ground and draw the free body diagram. So A is the one on the top that's sliding to the right. So it's got a rope pulling it to the right. It's got its weight going down, a normal force going up, and a friction opposing its sliding. So that's going to the left. No mysteries there. So now let us do block B. Free body diagram again, just statics. And it's got, why does it have 2T? Let's look back at our picture. Oh yeah, it's got two ropes pulling up on it and one weight pulling down on it. Pretty simple for that guy. Now let's come up with the force for these ones. Not the forces, but the kinetic diagrams. That's what we need. Block A is moving to the right. So it just has a MA to the right. We could have called that MAX, but it has no AY, so no need to complicate it there. And block B accelerating downward, right, as it is allowed to pull block A, it goes downward. So it'll have a downward acceleration like that. Really, that's all there is to our kinetic diagrams. And they'll get more complex, obviously, but we're starting here so that in the future we could then solve for unknown forces or accelerations. Wrap it up with another quiz. So the internal forces are not included in the equation of motion analysis because the internal forces are zero? Probably not, right? They're definitely, if something is being moved around, it's going to have some internal forces that are going to be stressing those materials, potentially deforming or breaking them if they're not strong enough. But that's a problem for another class, right? Mechanics of materials, and some of your other material design type courses. So when we're just talking about the motion caused by the external forces, the internal forces have no bearing on that. So it's not because they're equal to zero, it is because, yeah, they're equal and opposite and don't affect the calculations. Exactly. They're not negligibly small. They could be big enough to break the thing, but we're assuming our objects don't break, right? Our particle stays one particle, or later, our rigid body stays a rigid body and it doesn't change shape, it doesn't fall apart. Not important? Probably not. So a 10-pound block is moving down right now with a velocity v. The force F is applied to stop the block. Which one would be correct? Well, it looks like if it is sliding down, which way should the friction be? Pushing back up. So that's got to be A or C. Let's check out the difference. We've got, ooh, that's the only difference is mu k times 10 or mu k times normal force. Which one would be accurate? Just because this is 10 pounds or whatever, 10 newtons, does that necessarily make this normal force 10? Nah, this needs to be the normal force times mu, not that, right? We'd have to solve for N first to be able to plug it in and solve for our friction force. So that would need to be C. Okay, we'll pause it there and come back and actually solve now. Now that we've drawn our two diagrams, we can start solving for the unknowns.